In a previous lesson, we looked at this exact problem, and this was the final result from the work we did. And I just want to bring you back to that because this is the work that you're going to be doing today as well. Just it's going to be slightly more complicated equations because now your abilities have increased about what you can handle. So remember that when we did this problem, we saw that we basically had two equations that were set equal to each other. And so we were then able to basically look at each of those as their own equation, y equals each. And then when we do that, we then can graph each of those equations. So I graphed the quadratic from the left side. That gave me the parabola over there that you see on the graph. And I graphed the right side, the x minus 1. That was linear, so that was just the line that you see there. And then we found our answer by figuring out, okay, where do those two graphs cross? And in that particular case, they crossed in two places. So they crossed when x equaled 4, and they crossed where the x value was 7. Hence, 4 and 7 were our solutions. This same idea can apply to any equation. If you can graph the left side and the right side separately, your solutions will just be the x-coordinates where those two graphs cross. And then it's just a matter of seeing some of the little things that crop up along the way. For instance, in this particular problem that we had looked at before, there were two solutions because the graphs crossed twice. One of the things I'm going to want you to see today as we go through a couple more examples is that as you do these types of problems and solve them, sometimes there will be two solutions, sometimes there's one solution, sometimes there's no solutions at all, and it is even possible for there to be more than two solutions. We aren't going to delve into any of those today, but I just want you to realize that yes, it is also entirely possible for there to be any number of solutions, depending on the equations involved. All right, so the first equation we're going to be taking a look at here together as a new example is this one. Now, this is one that you did not do before, partly because when we first did those problems, we hadn't been graphing an absolute value equation that had those shifts in it. But in addition, we've also since then added in the reflections across the x-axis. So we're just adding in those other elements that you've been graphing. But all the same ideas of what you did originally with these types of problems are still present. So if I'm going to be solving this for x by graphing it, then I'm going to be taking the left side of the equation and setting it as y equals that for my first graph. And then I'm going to do y equals the right side of the equation. And I will be able to make that graph. And so I set up my two separate equations just like this. And now I graph each. I'm not going to delve into all the details of graphing. That's what we've been doing separately leading into this. So that stuff should actually be down by now. So I graph both of those two equations. And now that I have my graphs made, I need to figure out what my solutions are. Now remember, the solutions are where the graphs cross. I see a point where they cross here, and I see a point where they cross here. So it looks like I'm going to be seeing two solutions. Remember, I'm just giving the x-coordinates because my original equation just had x in it. There are no y's in the original. I just put the y's in so I could graph them. So my solutions are going to be x equals, and then I just go and I grab the x-coordinates where they cross. So the first one is 4, and the second one is 7. I actually gave you the same solutions as the last problem because the graph is actually pretty similar, but just kind of building that little bit so we could see how it worked with the absolute value graph in there. But of course, they will change up quite a bit as we go. So for instance, we might see a problem that looks more like this. Here we have a negative quadratic equal to a negative absolute value. Well, now I need to solve it. And I'm going to solve it by graphing it. And so the first thing I do is I break out the left and the right sides of that equation as their own equations that I can now go and graph. So set them both equal to y. And now I graph both of those equations. So for instance, for that first one, the negative out front tells me to reflect it across the x-axis. That is, instead of opening up from my first point, I'm going to open down from my first point. The plus 4, it is inside with x, and therefore it tells me to move it in the x direction. Plus tells me to go left. And the minus 1 hanging on the end, that tells me to shift everything down 1. And so I graph that one, and it is a quadratic, therefore I know it's the parabola shape, the U-shaped graph. And then I graph the absolute value after that. I know absolute value is the V-shaped graph, and it is also negative, which is why it's opening down. And now I look to see where they cross. And you'll notice that these two graphs actually do not cross anywhere. And because they do not cross anywhere, that means there's actually no solution to this particular equation. Now, one way that we could actually say that is to just actually write out no solution as you see it there. But, we often like to shorthand things, and so I'm going to shorthand it just a little bit as well. We would say here that the solution does not exist. And so for that reason, you can actually just abbreviate it as DNE. If you are doing a problem like this in WAMAP and there ends up being no solution, it specifically will be looking for you to type in DNE for does not exist. So just a little bit of a heads up there about how do you enter those answers when you see this come up on WAMAP. And I do mean when, not if. You will be seeing problems like this in today's assignment. All right, now we're just going to do one last problem to take a look at what happens as we do some of these various solutions by graphing. In this case, I have a square root set equal to an absolute value. Well, once again, I want to set it up as two separate equations. And now I'm going to graph each of those two separate equations. And now that I've graphed both of them, I need to find my solutions. And of course, the solutions are any place where the graphs cross. In this case, it looks like that happens only once. At this one point right here, they do touch. They barely touch, but they do in fact both touch that same point. And so I'm going to look down and grab the x-coordinate of that point, which is 3. Therefore, in this particular problem, x equals 3. Notice just one solution this time. You have to let the graph tell you how many solutions there are. And you can only do that by actually making the graphs and seeing. And so because they just happen to touch once, we happen to just have one solution. And that one now is done. The same principle will work for any other combinations that you see along the way. We did some combinations here with quadratics and absolute values, or here like the square root and absolute value. But of course, no matter what your function types are on both sides, you can still graph the left side, graph the right side, and just look to see where they intersect.